Hello, my name is Maverick Collins. This is my video submission for the determinant of a square matrix for CST-215 with instructor Nasser. So we are tasked with constructing a script that would compute the determinant of a given n by n matrix determined by the user. So what I went ahead and did was use the NumPy library to utilize the matrix functionality of that library. So from the very get, I prompt the user to enter a value for n to define the size of the square matrix n by n. We're then going to set the rows and the columns to whatever they input, square, so they're equivalent. And then going to print out the n by n matrix, rows, strings, and you'll see it here soon. So then after it outputs the string, we're then going to convert the rows and columns to int so we can use them in the matrix. So then I initialize the matrix using NumPy, creating a zeros matrix based off of the user input, whatever they inputted for n. So if it was 1, it'd be 1 by 1. If it was a 2, it'd be a 2 by 2. If it was 3, 3 by 2, 3, etc. So what this is go ahead and going to do is then it creates the matrix, and then so it's already initialized, and then we're going to reassign the value. So the user is going to then enter the value for each indice of the array. So if it's a 2 by 2, it's going to prompt the user to print the ith, jth element. So if it's a 2 by 2, it'll prompt the user, please enter a value for 0, 1. Please enter a value for, for 0, 0. Please enter a value for 0, 1. Please enter a value for 1, 0. Please enter a value for 1, 1. You get the idea. If it's a 3 by 3, there'll be 9 prompts for the user to answer. So then it's going to display the outputted or the inputted matrix back to the user just to confirm, hey, this is what you inputted, so the user can know what's going on. And then we'll get into the determinants here. So let me go ahead and run it before I get into the determinant. So here we go. Like I said, enter a value for n to define the square matrix. We're going to head and press 2. So it'll output, okay, you inputted size 2, 2 by 2. Okay, now enter a value for the position of each indice in the matrix. So 0, 0, we're just going to do 1, 0, 1, 2, 1, 0, 3, 1, 1, 4. And the reason I'm doing this because I know the determinant's -2. It's very easy to calculate. And boom. So I'm going to scroll up. So outputs the matrix back to the user so they can have a visual reminder of what they entered. And then it calculates the determinant, which is -2. And so again, it's going to work for 3 by 3 as well. For the sake of time, I won't get through it, but it'll work for n by n size matrix. So the first solution I did was to use the library. I quickly realized that that's not what was required of us. It works. I didn't end up utilizing it. I didn't print it, actually. Just going to comment that out because that was my initial solution. But this method here that I got from Geek for Geeks, I had to get some help because it was really difficult mathematically to implement. But basically what it's going to do is it's going to set up, it's going to pass through a matrix, the length of the matrix. It's then going to set up the temp values for storing each row. It's going to work its way through this for loop until it gets to the end of the matrix. And so there's going to be a counter, and the counter is going to circle through this while loop. So while the counter is, while it's inside the indice, while it's not at the end of the array, it's going to go through and check and see for these different use cases. So if there's a non-zero value, if there is a non-zero element for the determinant, and then it's going to go ahead and calculate the what do you call that? The inverse matrix, right? And that's what this loop is doing essentially. So it's going to go ahead and swap the values of the matrix and give you the inverse, which is used to calculate the determinant. and it's going to store them in this temporary matrix. And then down here is the business logic where it's actually then computing the determinant for the n by n matrix. Finally, it's going to output it and return it here below. And yeah, it's just a simple print statement with a format. And yeah, pretty seamless. This was definitely the heavy lifting. Again, a lot of help from Geek for Geeks. I cited it. It took a little bit of work getting the rows and the columns to work. Getting to work for user values. This took a little bit of creating the n-by-n matrix and just having it all visually look appealing for the user interface. I'd say it was most of of my where I shined the most. You know, this determinant functionality was very difficult to do. We'd only briefly touched on it in class, and I think maybe a more thorough depiction of it would have made the assignment a lot more approachable, I guess. But that's the power of the internet. We're able to utilize outside resources, and Geek for Geeks did a great job, kind of helping me step through it step by step and understanding what's going on with the business logic. So fun assignment, works for n by n, allows the user to enter values for the matrix, and yeah, it's pretty fun assignment. And if I were to do it again, I would probably try to add some more catch fail. So if the user enters a character as opposed to an integer, stuff like that, different error exceptions. So great assignment. Thanks for your time, and we'll see you in the next one.